In HARCO Project, you have been responsible for the development of some amazing technologies in what we call the functional bricks, so elementary elements, let me say, that are going to compose higher level modules and can be recombined according to different layout and according to different application. What is surprised me a lot is that some of your devices can really be employed in completely different task and industrial application. Can you give us an overview of what we have done?
Yes, we have been targeting a number of modules that can go together to form adaptronic modules that will be useful in a range of very different applications. But the fundamental building blocks are quite simple. Basically, what we need is compact solutions for actuators, but unfortunately what we tend to find is we very often need compact actuators which have quite high force capability, and that isn't something that is always available in what's currently on the market. We also want to have displacement transducers. Very often we need to measure where something has gone if it's something where we're trying to do any sort of a displacement to regain a position. And the other area that we find is very important to us is in elements that can help us deal with dynamics problems in machines, because very often in these days with higher speed machines and very accurate machines, it's the dynamics of the machine which limit the capabilities. So we're quite interested in vibration control in various means. So we are interested in using simple devices like passive dampers, but making them adaptable by tuning them. So to this end, we also then need to have actuators to tune the dampers. So we have developed a range of quite different simple bricks, but they can be combined together to produce different, slightly more complex devices. Always, we hope, at low cost, always we hope very robustly, and always we hope with high performance. So the sorts of things we've got now, we have a very compact flat pancake actuator. We've made it as a hydraulic actuator which is driven by a servo drive rather than a conventional pump, so we get away with all the need to have conventional hydraulics there. We've made a whole family of these for different applications. We've made some rather interesting displacement sensors based on fibre optics that allow us to measure in various numbers of axes. So we can make a one-axis one for a straight displacement in one axis, or we can make a two-axis one which will give us displacement and tilt, or a three-axis one. And we have also made a very simple tunable damper. And it's a tunable damper based on rubber elastic spring elements that also provide the damping. And we use one of the hydraulic actuators to deform or squash the rubber stiffness unit, changing its stiffness and therefore changing the frequency, and we have very simple then robust tunable vibration absorbers. We've added to that a couple of support technologies, so we have an adaptive control algorithm that will follow the frequency, so it detects peaks and will tune to peaks within a range, or it will just track the frequency of a vibration up and down, tuning the damper to take the disturbance away. And we have also found that one of the things that was limiting us in producing these devices quite quickly was that we were using rubber elements, and we were having to cut simple shapes out of different materials to get different stiffnesses, and we've found a rather interesting way now of producing non-linear damping elements very quickly by actually using shaped deforming elements, which means that we can produce different elements of stiffness and damping very quickly just using simple sheet materials. So we put the whole lot together and we can rapidly produce solutions to dynamics problems to the requirement that is there.
Simplicity seems one of the of your favorite words, and classic technologies recombined, adapted, modified in order to solve problems that nowadays seems the typical field for very complex adaptronic solutions. How do you address your potential customers' perception about these classic technologies against more modern and definitely more expensive solutions?
It can be a problem because sometimes if a device is very elegant and simple and it does the job, people don't see why they should pay a lot of money for something which looks as if it's quite simple. On the other hand, there is the point that if somebody has got a problem that is causing them a lot of pain, then they tend to be quite happy to pay for a solution. So one of the routes that we see as being very important is to make sure that we don't fall foul of customer perception. And one of the ways that we see it being very, very useful to us is we actually have some monitoring technology that we use in a lot of areas, and we quite often employ that to go and investigate problems at customer sites. And if we produce the solutions so they're compatible with these monitoring and also control devices, then people are already in the mindset that they are looking at a severe problem. They are prepared probably to invest in monitoring devices. So actually just turning that round to actually have something which is doing the control and solving the problem is something they will bite your hand off for, because they actually get a solution very, very rapidly. And we can prototype it and demonstrate it actually while we're measuring and identifying what the problem is. So it has a benefit for us. It eases our sales activity, it eases us with the customer's perception, and it allows us to prove out the whole thing exactly on site where it needs to be proven out. So it's probably the strategy that will get around that problem.